Welcome everyone, and thank you for joining DoubleRadius as we host today's webinar with RF Elements entitled Optimizing Your Network with Innovative Antennas. My name is Chad Crossland and I'm the marketing manager here at DoubleRadius. For those who are new to DoubleRadius, we're a value-added distributor of wireless network solutions. Since 2001, we've been helping service providers, systems integrators, municipalities, telcos, and others to build better networks. We operate out of 2 locations, our headquarters here in Charlotte, North Carolina, as well as our facility in Salt Lake City, Utah. Just a little housekeeping before we start. Throughout the webinar, if you have any questions on the material that's being presented, go ahead and enter those into the questions box, and this will allow us to answer those during the Q&A portion at the end of the webinar. And after the Q&A, please also just take a brief moment to complete the survey that will appear on your screen, and your feedback will be very much appreciated. With that being said, I'd like to introduce our speaker for today. Tasos Alexiou is a product evangelist and horn antenna expert at RF Elements. We're glad to have him with us today. And Tasos, the floor is yours, so take it away.
Excellent. Thank you, Chad. Thank you, everybody, for joining us today. My name is Tasos. Again, I'm with RF Elements, and I am a horn antenna or product expert. And today we'll be going through our product overview and discussing our current product line, the features and functions that make them very unique, and how they can potentially help your WISP. As Chad mentioned earlier, again, as I go through the webinar, we'll take all questions at the end. So if you see anything or hear anything that doesn't make sense, please feel free to ask that question. And so that way I can clarify some answers towards the end. So with that said, we'll get started here. So this is our current product map, all the products that we're currently offering, and we break it down into 3 different types of different product types. The first group are our symmetrical beam antennas, and these are antennas that have beam shapes that are symmetrical. Where that the elevation cut is basically the same width as the azimuth cut. So it's a symmetrical beam pattern. Our second grouping of products are our asymmetrical beam antennas. So these antennas have, again, asymmetrical beam shapes. So typically the azimuth shape or the width of the antenna beam is usually much wider than it is tall in the elevation cut. So this would be our asymmetrical beam antennas. And then the third product type at the bottom is our TWISTPORT adapters. So our TWISTPORT adapters are our unique adapters that allow you to interface many popular third-party connectorized radios that are on the market today, and allow you to interface these radios with any of our TWISTPORT enabled antennas. So this here is our TWISTPORT. This is our proprietary design. The TWISTPORT is an actual waveguide interface, and it allows us to connect TWISTPORT enabled radio systems to our antennas and gives us a very simple, smooth, and efficient way of transmitting the RF energy from the radio to the antenna. So it's not only the RF interface, but it's also the mounting or connection interface from, again, the radio to the antenna. Our TWISTPORT kind of ecosystem or design is practically zero loss or near zero loss. So we created a reference design that would eliminate the pigtail connectors that you have currently, the external pigtail connectors of your kind of, standard or your older industry standard radios, and therefore reducing the amount of RF loss that is created when you try and transmit the power from your radio into your antenna. So again, the TWISTPORT brings zero or near zero loss to our antenna system. So what is a TWISTPORT adapter? An adapter is simply that. It adapts connectorized radios to our waveguide interface. If we look under the hood of our TWISTPORT adapter, we will see pigtails and connectors. That's the only way to convert connectorized radios to a waveguide interface. The key here is that our pigtails are protected underneath the cover, so they're not exposed to the elements. And we also use semi-rigid pigtails with very calibrated and fixed bends to them to enable very good VSWR and extremely low loss. So even though we have pigtails underneath the cover of the TWISTPORT adapter, we still see near zero loss and a very efficient transmission medium from the radio to the antenna. So that's what our TWISTPORT adapters do. Aren't familiar with our product line and maybe haven't seen our TWISTPORT enabled radios or antennas, this is the system that we have today. So we have many different antenna types, everything from symmetrical horn antennas, which I mentioned earlier, to asymmetrical horn antennas, which you can see on the right, to very high gain directional horn antennas that you can see in the center of the picture, to even a parabolic dish line that's also waveguide fed. And again, all of these TWISTPORT enabled antennas work with any of our TWISTPORT adapters. As I mentioned earlier, we make TWISTPORT adapters for many of the common connectorized small form factor radios on the market. Cambium is just one of those manufacturers that we support with TWISTPORT adapters. So if you're running EPMP 1000 radios, we have a TWISTPORT adapter specifically for that radio. It's the TWISTPORT adapter EPMP. As you can see, our TWISTPORT adapters are very easy to use. The radio just simply slides up inside the adapter, clicks and locks in place, and then simply by pressing a button, you can drop the radio out and disconnect it from the adapter if need be. So this EPMP 1000 adapter supports, I believe, the 3 different variants of EPMP 1000, which is like the EPMP 1000, the 1000 Lite, and I believe there's also a 1000 Sync that has GPS synchronization. So any of those have the same form factor and would utilize the same exact adapter. If you're running EPMP 2000, we support that radio again with a unique adapter specifically for that radio. As you saw with the previous radio, again, they just simply slide up, lock in place, and then therefore get converted to our TWISTPORT waveguide interface. A thing to remember that when we use a TWISTPORT adapter, we're also protecting the pigtails from outdoor influences like water ingress or birds that may chip away or chew on your cable, or squirrels and other things. So everything is protected underneath the adapter, and therefore, again, giving you a more robust connectorized radio interface via our waveguide to our antennas. We recently added support for the new EPMP 3000 line. So if you're running the EPMP 3000 CSM, which I believe is the client-side radio from Cambium Networks, again, we have a TWISTPORT adapter that works for that as well. And like all of them, you can see they just simply slide up inside the adapter and lock in place. We also support the EPMP 3000L. The 3000L is the newer 2x2 256 QAM AP radio with GPS synchronization from Cambium Networks. So again, if you're running this 3000L, you'll be able to utilize this EPMP adapter with that radio and all the other previous radios that we've shown from Cambium Networks. So quite simple to use. If you run Microtech, we have a couple of different adapters for Microtech as well. So the first one we have is our TWISTPORT adapter RBP, which is router board plastic. It's a plastic enclosure that simply works with most of the small form factor router boards like the 411 series, the 711 series, the 911 series, and even the new M11 series router boards from Microtech. So as you can see, you simply open up the bottom lid, you slide out the slider, and then you screw your board into place into the slider, connect your pigtails internally, and then slide it up inside the enclosure. And now you have a waveguide enabled router board. For those customers running Microtech that prefer a full die-cast enclosure, we have the TWISTPORT adapter RBC for router board cast. Again, this adapter works for most of the small form factor square Microtech boards, including the M11 series. Again, I believe the 411U is probably the only board that doesn't work with these adapters, but most of the other ones work just fine. Again, you insert your router board, make your connections with the internal pigtails, and then you get a full die cast, full O-ring sealed, waveguide fed Microtech radio to work with all of our TWISTPORT enabled antennas. Ubiquiti Networks is again another manufacturer that we support TWISTPORT adapters for their small form factor radios. Ubiquiti makes the largest number of radios that we formally have support for. So if you're running the ISOSTATION, which is Ubiquiti's waveguide round form factor radio, we have an adapter which is called a TWISTPORT adapter IS for ISOSTATION. This adapter also works for their round form factor PRISM station, which is the AP version of their kind of waveguide fed round form factor radio system. So this TWISTPORT adapter has absolutely zero pigtails because again, we're starting with a radio that's originally waveguide fed. So this adapter simply converts their waveguide interface into our waveguide interface. So that way you can utilize, again, the ISOSTATION or the PRISM station with any of our TWISTPORT antennas. For full compatibility, again, the ISOSTATION M5, the ISOSTATION 5AC, and the PRISM station 5AC from Ubiquiti. All three of these round form factor radios work with the single ISOSTATION adapter. Again, just a waveguide converter, so that way you can utilize any of these platforms with any of our TWISTPORT antennas. If you're running the Rocket 5 AC Prism or the AirFiber 5X line of radios from Ubiquiti, we have the TWISTPORT adapter PAF, PAF, which stands for Prism AirFiber. Here we see the AirFiber adapter being added to the back of the radio, allowing you to simply slide in and lock into place the AirFiber radio platform. The same with the Prism or the Rocket 5 AC Prism from Ubiquiti does not require that additional adapter, which is included. You simply just take that radio and you slide it in and lock it into place without the use of the adapter. Again, pressing the radio release button will allow you to remove that radio if you need to upgrade or change or do some sort of maintenance. So again, the TWISTPORT adapter PAF works with the Rocket 5 Prism and the AirFiber 5X line. Another really unique property or function of this particular adapter is we integrated the GPS antenna into it. So not only are the pigtails from the RF side protected, now your GPS antenna and GPS cable is fully protected inside of this adapter. So the GPS puck that's supplied with either the AirFiber or the Rocket Prism radio simply just mounts in that little slot, and then you're able to coil the wire safely all underneath the hood, and therefore protecting that GPS puck from, again, any outside influences, as well as, again, helping you, in some cases, you can't always find a place or a metallic surface to mount the GPS antenna to. So everything is nicely tucked inside underneath the hood and therefore protected from the environment, which is a really cool feature of this particular TWISTPORT adapter. As far as full compatibility goes, again, this single adapter works for the Rocket Prism 5 AC, the Rocket Prism 5 AC Generation 2 or Gen 2 rocket, the Airfiber 5X, which is the older version, and the more updated Airfiber 5X HD, which has been called the LTU radio as well. So any of these particular radios from Ubiquiti are supported from this one single adapter, and again, making them all compatible with any of our TWISTPORT enabled antennas. If you're running some legacy equipment, there's quite a install base out there of the older Rocket M5 radios. So if you're running the Rocket M5, we have the TWISTPORT adapter RM5, which allow you to again use the Rocket and interface with our antenna system. Along with that is the Rocket 5 AC, also known as the AC Lite. So this is Ubiquiti's first generation AC access point that came out. So if you're running the Rocket 5 AC Lite, you can use the TWISTPORT adapter R5 AC and again enjoy all the benefits that any of our TWISTPORT enabled antennas bring to you. Finally, we move on to Mimosa networks. So anybody who's running Mimosa on their networks, we have a single adapter for the C5C radio from Mimosa. So whether you're using the C5C for a point-to-point link or you're using it on the client side of a point-to-multipoint link, we have a single adapter for the C5C from Mimosa Networks. So that's the TWISTPORT adapter C5C. Quite simple, again, just like all of our adapters, simply slide and lock into place, and you can press the button to safely release it if you need to. For all other 5 gigahertz radios on the market, we have a connectorized TWISTPORT adapter. So TWISTPORT adapters, as I mentioned earlier, are really designed and made for smaller form factor radios. There are a lot of larger form factor 5 gigahertz radios. For instance, the Mimosa A5C. It's a very heavy, large, and complex type enclosure that's not suitable for a TWISTPORT adapter. Perhaps you're running the Cambium PMP 450i, or maybe you're doing a backhaul with the Cambium PTP 550, or even the Mimosa B5C. For all these large, heavy form factor radios, which we do not have a TWISTPORT adapter for, we have the connectorized version now. So it's quite simple. Again, it's a waveguide feed with 2 SMA connectors on there. So simply, you will get a LMR cable with SMA to whatever connector type you have on your current radio, which a TWISTPORT adapter isn't made for. And you could, again, utilize all of our TWISTPORT enabled radios. This also would cover Microtech with the, what's it called, the router box or one of these other radios that might be out there. So again, any 5 gig radio, which we do not make a TWISTPORT adapter for, this is the adapter for you, the connectorized TWISTPORT adapter. Very simple. So TWISTPORT adapter SMA. So that was our complete line of TWISTPORT adapters that we have available. So now we'll be moving on to our symmetrical beam shape antennas, starting with our symmetrical horn antennas. So the symmetrical horn antennas are the first horn antenna type that we brought to market. We have seven different variants of the symmetrical horn antenna. This is our generation 2. And as you can see from here, we make everything from a 30-degree wide symmetrical beam to a 90-degree symmetrical beam in 10-degree steps. So everything from 30, 40, 50, 60, 70, 80, and 90 degree. For those of you who've never seen our products, maybe you haven't gone to a WISPA show or a MUM event or something like that, this is what our symmetrical horn Gen 2 antennas look like. So as I mentioned, the symmetrical horns have a symmetrical beam. So the azimuth cut and the elevation cut are identical, right? So if you look at the beam shape, you can see it's just as wide as it is tall. So it's very symmetrical, and this gives you some very unique properties of the antenna. So symmetrical beam being the main focus point of this topic. If we compare that beam shape to traditional sectors, as you can see on the left-hand side, you can see the beam is quite different, right? Not only do you see it's not as flat and narrow in the elevation cut as a traditional sector, but you can see all the side lobes that exist in traditional sectors. These are all the secondary RF beam shapes that come off of a traditional sector that are typically on the top, the bottom, out the back, and off to the extreme edges of a traditional sector. A symmetrical horn antenna has absolutely 0 side lobes, and this is one of the most important features of our antennas that give you all the noise immunity by creating an extremely precise radiation angle that you just don't get with traditional sectors. Here we're looking at an RF simulation, right? So we're looking at a 90-degree symmetrical horn on the left compared to a competitive patch array sector on your right. On your right is the, again, your kind of traditional long rectangular sector that most WISPs have been using. And you can see how clean the RF signature is coming off of a symmetrical horn. It's very precise, it's very uniform, and with practically 0 leakage. If you look at patch array antennas, they have very huge and complex side lobes. Not only do the side lobes create issues for receiving noise, they also typically go all around the antenna. So you can see how traditional sectors are able to pick up a lot more noise from behind or the extreme edge of the antenna. This particular antenna could be practically classified as an omni because it goes in 360 degrees. So very sloppy beam pattern with absolutely 0 precision. So you don't know where your signal is going. And symmetrical horns give you the ability to have very precise radiation angles, and therefore gives you the ultimate control of your RF signature from your tower or your access point. Another pretty cool feature or thing that you get from horn antennas, because they have typically larger elevation cuts, you get a much smaller null zone or dead zone underneath your tower. A lot of you probably have noticed when you have traditional sectors high up on a tower or high up on a mountain, you get a very big dead zone close into the antenna itself. And this is because, again, how the elevation cut of traditional sectors is much more narrow. On symmetrical horn antennas, because they're much larger, you get practically 0 dead zone, or you can see in relation to a traditional sector, it's much, much smaller. So therefore, you can cover your close-in clients and your further out clients, again, with nothing but main beam connectivity and 0 side lobes. Another great feature that horn antennas bring is frequency stability. So as we sweep through the 5 gig spectrum from the lower 5 up even into the 6 gigahertz spectrum, you can see that the main beam of the antenna really doesn't shift much or change much. You can see it a lot better on the 2-dimensional picture on the right of your coverage map. So as we change channels, our coverage area is not changing. So it's not changing as much. So it's much more stable across the frequency spectrum than traditional sectors. Here you can see how the instability of a patch array sector creates many more side lobes and much more complicated side lobes as we change frequencies. And this is really important if you look at the 2-dimensional picture variation on the right. As we change frequency, you can see how your coverage area is changing. And this is one of the biggest problems with traditional sectors. I'm sure many of you have gone out and done your installation, and you have your customers on and everything is great, right? You start off, you pick a good channel, you deploy your customers, or you sign up your customers, and then at some point noise plays a part and you have to change a channel because maybe a competitor is using the same channel facing your sector. So you choose a different channel. And then all of a sudden you have customers that drop off. You have customers that had great signal that now have marginal. You have customers that had marginal that now have no signal or extremely low modulation rates. And this is usually understood or interpreted as there's still noise on this new channel that you picked, and chances are that's not the case. What it is your coverage area has changed, and that customer that used to have decent signal now is in a dead zone or doesn't have coverage any longer because the frequency has changed. So this is very catastrophic and makes it very difficult for WISPs to, again, manage frequencies and manage the growth of their WISP. So the frequency instability of a patch array or traditional sector is highly unstable, and we can see that here from the simulations. Another unique property to horn antennas, it's very high signal density, right? So as we look at how the gain drops off on a horn antenna as you go to the edge of the coverage area, the edge of the sector, or edge of the horn, you can see that signal drops off extremely fast with a horn antenna. This is one of the reasons why we get such high noise immunity. Not only is the beam extremely precise, so it's only really facing the area in which you want to cover and therefore not hearing noise outside of that area, but also that quick drop off allows you to co-locate these horn antennas in a very high density on towers as well. If we look on the right, you can see the kind of bleed off of a traditional sector. So again, the bleed off is much slower as you go to the edge, and this is why many WISPs use or deploy a 60 or 90 degree traditional sector, and they end up going out to 120 or even 180 degrees. So this really, again, low signal density and the bleed off of gain at the edge being so slow makes, again, patch array sectors not precise at all, and therefore very hard to manage your coverage area. And then you can only imagine how much more difficult it is to co-locate a bunch of these kind of sloppy beam patterns on a actual tower or a cell site. So signal density, again, is what gets you the noise immunity that horn antennas bring. I mentioned earlier that the symmetrical horn series of antennas have 7 different variants, everything from 30 to 90 in 10-degree steps. The most important thing to keep note of here is the relationship of gain to beam angle. So the wider you go in beam angle, the lower the gain is because it's less focused, right? So our 30-degree symmetrical horn on the top left has about 18.5 dBi of gain. Now, if you compare that to our 90-degree symmetrical horn, it only has about 9.6 or 9.5 dBi of gain, and that's on the bottom right of your screen. This is often understood or misexplained by many people in that, again, you can't compare a 90-degree patch array sector to a 90-degree symmetrical horn because simply the gain difference is too large. So a 90-degree symmetrical horn in no way is a pure replacement for any 90-degree traditional sector. So again, you just have to look at the gain number. So don't expect a 90-degree symmetrical horn to outperform a 17 or 18 dBi 90-degree traditional sector because, again, the gain difference is too large. So just there's reasons for this lower gain, and it's for utilizing these antennas for different things. Our 90-degree symmetrical horn is fantastic for micro pops, right, where you're only trying to go about a mile or less. Why would you use such a high gain traditional sector that has anywhere from 5 to maybe even 7 dBi more gain that just gives you bigger ears to hear much more noise? So again, the lower gain, wider symmetrical horns are great for, again, kind of short distance micro pops and other types of deployments. The compact size of our symmetrical horns is, again, something that's very unique and something that's very helpful. In most cases, it's about a quarter or a third of the side of a traditional sector. So this allows you to get 2, 3 to maybe 4 times the AP density on the same vertical space of your traditional sector. You know, one way to grow, you know, your user base, and one way to get more customers online from your tower is to add more access points. And symmetrical horns compact size allows you to, again, mount way more AP density in the same vertical space than your traditional sectors allow you to. So all this stuff, when it comes together, really creates this co-location miracle. Again, you get extremely high network throughput from your tower when you use our symmetrical horns, because they allow you to install so many more access points, again, on any particular tower than traditional sectors do. So that's just the AP density side of co-location. Because of, again, the precise radiation angles, the signal density, and the very sharp drop-off. If you look at, you know, competitive sector antennas with all the side lobes interact with each other, create noise, and make it very difficult to co-locate the same amount of density or even close to the same density as horn antennas allow you. We could even, you know, go into wind loading and weight and all the other things and other benefits of the small form factor of a horn. So it really is a co-location miracle. Again, here is just some real world installs of what people are doing with our symmetrical horns. So you can see that they're practically mounting them about a foot apart from each other. And these things are working fantastic with GPS synchronization. So really, the density that we say and we show in all of our animations, you can see here in real life being done every day by WISPs on the market today. The amount of access points per tower are growing every day as WISPs push the limits of our antennas. I think we're currently up to over 30 APs on one tower using symmetrical horns, and I think that would be quite difficult to do with your traditional sector. And symmetrical horn antennas, or a horn antenna technology, really allows you to do that and get to this massive scalability. Again, you know, we have 7 different variants of our symmetrical horn antennas, and they're all used for different things. You know, you can utilize them to use lower gain when you're facing, you know, one of your other tower sectors, so that way you don't hear it as much, right? So there's a lot of different reasons why you might use a particular beam or a particular size symmetrical horn. Again, for higher density, you probably use the more narrow ones. For less range, you could use the more wider ones and lower gain. So this massive scalability is only available and possible with our horn antenna technology. So all of our antennas, again, are very durable and built very well. We use high quality materials when we build our antennas, from, you know, rust-free aluminum and stainless steel to you know, high quality UV rated plastics, including HPDE, as well as ABS plastics. So again, our antennas are built very well, and they're built to last and to reuse later down the line. So your investment is not wasted with our horn antennas. Again, just looking at some more deployments here, you can see you know, Microtech router boards being used on the right. You can see old Rocket M5s being used on the left, and in the center here is actually the older Rocket PTP PRISM. So again, a lot of different radios are being used today, and these are the Rocket PRISM Gen 2 radios that most people, a lot of WISPs are using today. So again, really high density. These are real deployments. These are real WISPs, not just specs on a spec sheet. So the next antenna that we're moving on to in our symmetrical beam shape antenna line is the ULTRAHORN. So many of you may have heard of our ULTRAHORN. This is our very high gain, very directional horn antenna. This horn antenna comes in a 15-degree wide beam angle and has 24 dBi of gain. So again, just like the previous antenna types that we spoke about, the ULTRAHORN has a very highly precise beam. It's 15 degrees wide and 15 degrees tall, so it's very symmetrical, but it's also highly focused, delivering much more gain. Just like our symmetrical horn antennas, the ULTRAHORN also has very great frequency stability. So again, as we sweep through the frequency spectrum from the lower 5 gig to the upper 5 and even into the 6 gigahertz spectrum, you can see that the beam shape of the main beam is very stable and doesn't change very much. We also have 0 side lobes. So if you look on the left, we can compare a parabolic dish antenna to our ULTRAHORN. So you can see all the side lobes that are in a parabolic dish antenna that make parabolic dish antennas great noise receptors, which is a huge, huge no-no. The more you grow gain on a parabolic dish antenna, the more you grow the intensity of the side lobes. And the side lobes are often so large that they can hear from a very, very far distance, right? So not only is it difficult for parabolic dish backhauls to coexist with other competitors' towers, but you can imagine again how much more difficult it is to co-locate many backhauls on the same tower when you have such large side lobes coming off, again, the top, bottom, sides, and even the back of a parabolic dish antenna. Where on the right with the ULTRAHORN, again, you can see there's absolutely 0 side lobes, so you get very good control and very precise radiation angles on an ULTRAHORN compared to a dish antenna. So here we're looking at, again, another RF simulation and what we call the shroud effect. So many users say, well, yeah, I know parabolic dish antennas have side lobes, so I'm going to go ahead and waste more money and buy a shroud. This is this round dome you put around the outside perimeter of an antenna. It looks like a drum that you put on there. And the shroud is supposed to, again, reduce side lobes, and simply it's untrue. So if you look at the parabolic dish on the left without a shroud, you can see all the side lobes that come out. If you look down the center, you can see the very dense green. This is the main beam. This is, you know, that 8 or 10 degree or 6 degree wide beam that everybody buys their antennas based on, but nobody pays attention to how wide these side lobes go. So this parabolic dish, even though it has a very narrow beam angle, it's still going, again, you know, 30, 50, even 180 degrees wide with a lot of RF leaking out the back. When you add a shroud, this is the same antenna on the right-hand side, all you're doing is taking that RF side lobe energy and you're just smushing it forward and getting it further away from the back of the antenna. So you will see with a shroud perhaps better co-location capability because there's less leaking out the back, but you can still see the sides are still extremely leaky. And it really, the most important thing is it totally changes the RF characteristics of the main beam. So when you buy this parabolic dish antenna, because of, you know, what you see in the polar plots or you see in the gain or you see whatever on their data sheet that you were impressed with and that's why you bought it, when you add this aftermarket shroud, you've now changed all those parameters. So that antenna no longer possesses the same RF characteristics in which you bought that parabolic dish antenna for. So the shroud really changes everything, including the most important part, which is the forward-facing RF that talks to the other end of the link. So not a great idea. Here it is in 3D without a shroud, and you can see when we add a shroud, all it does is just focus that energy more forward, actually making the forward-facing RF much wider than it was before, and therefore, again, not giving you what you would perceive you would get without the shroud. So the shroud is really not the best idea for creating noise immunity. Here we can see again the difference between an ULTRAHORN on the left and that same parabolic dish on the right. Again, if you look at it, a lot of people will say, well, your horn is only 15 degrees wide in the main beam, which is much wider than my 8 degree main beam of my parabolic dish. but nobody is looking at all the side lobes. So you can see how a parabolic dish is actually much wider than a symmetrical horn, because at least with the symmetrical horn, we have a very precise, highly controlled 15-degree beam with 0 side lobes. So this is where the real magic comes from, and this antenna, I'm telling you, is by far one of the best backhaul antennas that you can get. Again, understanding the gain relationship for specific links as long as it's within the link calculation. So true noise rejection comes from the ULTRAHORN. One of the other performance enhancements or characteristics of our horn antennas is its very uniform gain, right? So if we look at the gain curve across the entire spectrum, we can draw that gain curve with a single line, and that's because our vertical and horizontal beam gain is identical at every frequency across the spectrum. This is, again, really important, especially when you're deploying a backhaul, let's say in the upper Uni 3, where you might have the highest gain from a parabolic dish antenna. And then for whatever reason, maybe you have to switch to Uni 1 or Uni 2 in the lower bands, which have lower EIRP outputs available. And now where you thought you had much higher gain in a parabolic, the actual performance at that particular spectrum is much lower. So with a ULTRAHORN or with our horn antennas, when you change frequencies, you know you're still getting plus or minus 1 to 2 dB max of deviation in gain. So therefore, you know, no matter what frequency you go to, you're getting the same amount of gain being delivered, and also you're getting it in both vertical and horizontal polarities, which is highly important to make sure that your chain-to-chain performance and magnitude of signal stay the same. Easy antenna alignment happens when you use ULTRAHORNs. You no longer have to worry about connecting to side lobes. There are no side lobe connections. So this is a big problem with parabolic dish antennas, especially with new installers connecting via side lobe. With an ULTRAHORN on the left, you can see that you're either in connectivity or you're out. So there is no questioning whether or not you've made a link. This really starts to show up when you're using too much gain in a parabolic at a short distance, because it's easy to get a high neg 50 or something like that, or even a high neg 40 on your connection, and you think, you know, hey, that's an acceptable signal level, but you could be connected to a side lobe. And this is one of the reasons why you'll see people ask questions on forums or on Facebook saying, hey, I did this 2-mile shot with 31 dBi dish antennas, I got neg 50 signal, but my CCQ is horrible, or I'm getting, you know, packets dropped, or I'm not getting full modulation rate. Why is this? And that's because, again, you're not making main beam to main beam connectivity. Side lobe connectivity really destroys the performance of your radios. And again, easier alignment and more guaranteed main beam connectivity means overall better performance for your links when you use an ULTRAHORN. A question that comes up often is, you know, is the ULTRAHORN really a high performance point-to-point or point-to-multi-point antenna? And really, the antenna doesn't care. It really doesn't matter. As long as the beam shape fits your particular deployment, you can use it for point-to-point on the left, or if you have a high cluster of customers within that 15-degree, there's no reason why you cannot use the ULTRAHORN for a point-to-multi-point antenna. Actually, many customers are doing that today. You know, we're building so much density with these 30-degree symmetrical horns that we have that, you know, the density or the number of clients per AP is still exceeding the radio's ability to keep up. So people are now starting to cut 30-degree beams into 2 15-degree beams to get more AP density with our ULTRAHORN. So again, it really doesn't matter if you need the gain, if you need to use it for point to multi-point, there's no reason why you couldn't use an ULTRAHORN for either type of deployment. Just like our symmetrical horns, again, they're built like a tank. Actually, I wouldn't even use durable. I mean, these things are monsters. Again, we use very high quality stainless, aluminum, zinc, and again, high, you know, HPDE type plastics. So again, they're built to last, and they're built to to really be robust when out in the field. So very well built. You will not be disappointed with the quality of this antenna. If we look at some of the deployments again here, you can see in the middle and the left, this is a WISP, I believe, in Australia that's using ULTRAHORN specifically for point to multipoint. So here is again a bunch of 15-degree tight beams for point to multipoint. So quite amazing what you can do with the ULTRAHORN. It's very versatile. If you look on the right, this is quite an amazing shot as well. So this is a backhaul with an EPMP 1000. So this particular customer had a 15-mile link with EPMP 1000 on 30 dBi dishes. This was a backup link to a licensed link that he had in the same direction. He had problems every day with thermal fade. In the morning, he would start losing the link due to thermal inversion. Plus, even when thermal inversion wasn't there, he didn't get solid MCS rates. The modulation rate was jumping around because of noise. So he replaced a 30 dBi dish with only a 24 dBi ULTRAHORN going 15 miles. Not only is he solid MCS9, MCS7 64 QAM on this radio all day long, but his thermal inversion problem went away as well. And this is because we have a larger main beam. So even though thermal inversion is still happening with the RF that's coming out of the antenna, because the beam is no longer 6 degrees tall, when it deflects and an inversion starts to happen, you can still have the main beam stay in connection. So he's now currently, after a year of having this as a backup, he's now running VoIP over this particular line. So it's become so stable and he's so comfortable with it that it went from a backup to now passing VoIP traffic over it. So quite amazing, quite amazing. Again, some other deployments that are being used. Again, you can see a backhaul in between two sectors, and again, just basically the ULTRAHORN in the wild. It's really starting to take off, and people are really starting to understand that, you know, you don't need massive amounts of gain for every link. Sure, if you're doing a 15 or 20 mile link, you're not going to think about doing it with an ULTRAHORN. But if it's 10 miles or less, again, depending on which radio platform you use, 24 dBi of gain is plenty for many of the radio platforms that are out there. So it's a great antenna, great stability, and the RF performance is just unmatched out there today. So next we'll move into our ULTRADISH. The ULTRADISH is our parabolic dish line of TWISTPORT antennas. Again, it's a waveguide fed parabolic dish antenna. We offer two different variants of the ULTRADISH. We have a 27.5 dBi version, which is 550 millimeters. And then we have a smaller 400 millimeter version, which is 24.5 dBi of gain. So depending on whether you're trying to use it for backhaul or a high-end client or long-range client, again, we have two different sizes to try and accommodate you with. So like any parabolic dish antenna, parabolic dish antennas have side lobes, as do ours, right? We have done many good things with our ULTRADISH to try and make it perform as well as possible without the using shielding, without the need. So we've been able to design the reflector and feed horn of our ULTRADISH to try and suppress side lobes, right? So although we do have side lobes, we have pretty decent side lobe suppression. So we have great performance there, again, without having to add an aftermarket shroud and therefore ruining all the great beam performance characteristics that we have created with our ULTRADISH line of antennas. One of those great performing things is the stable gain. So again, if you look at our gain curve in both the 400 and the 550 series of ULTRADISH, you can see gain is practically flat again across the entire usable spectrum for 5 gig. Again, the vertical and horizontal beam gain is also identical, which is one of the other things that we spent a lot of time trying to achieve, not only stable gain, but also stable gain in both polarities. So again, if you use this as a CPE or you use it as a backhaul, if you have to change frequencies, you know that you're getting pretty much the same amount of gain no matter where you are in the 5 gig spectrum. So huge improvements over other parabolic dish antennas, and certainly no need for shrouds. They're great in high noise environments, right? So a lot of people like to use panel antennas, right? Those square patch array panel antennas, the CPEs, in high density deployments. And you can see the side lobes are capable of hearing multiple APs at the same time, which really create a lot of problems with noise. With these side lobe suppression and great performance, again, you have a higher probability of not hearing as many APs in some of these high AP or high density AP deployments because we have good side lobe suppression. So they're great in high noise areas compared to, again, some patch array, those square form factor panel antennas that a lot of WISPs use for CPEs out in the market. We also have an innovative mount, right? So our mount is something that's quite unique in the market. I mean, pretty much you mount the interface to the pole, and then you simply drop and slide the dish antenna into the mount, and it allows you to then adjust your azimuth and lock it in, and also adjust your elevation and then lock it in as well. So really you only need one tool. In a lot of cases you can actually deploy and mount this with practically one hand, again, because it's only 2 bolts to get the whole antenna system mounted to the tower. So it's greatly improved over the, again, overabundance of nuts, washers, and bolts, and all these other parts that other dish antenna manufacturers have. A lot of dish manufacturers now have, multi-piece radomes as well that, may require, dozens and dozens of screws and nuts to put those things together. So again, our mount is very innovative and something quite new in the market. So a great benefit of our ULTRADISH. Again, looking at some deployments here, you can see again our ULTRADISH used for backhaul and even client-side antennas. Really, it's up to you how you use it and with which radio platform you decide to use it with. So very versatile, very well priced, and absolutely fantastic performance from our ULTRADISH. So now we'll move into our asymmetrical beam pattern antennas, and these are our new asymmetrical horn antennas. So the asymmetrical horns come in 3 different flavors. We have a 30-degree wide, a 60-degree wide, and now a 90-degree wide asymmetrical horn. So the big difference between our asymmetrical horns and the original symmetrical horns that we were talking about is, again, the beam shape is asymmetrical. So here you can see now our 90-degree asymmetrical horn on the left has 16 dBi of gain compared to the 9.5 dBi of gain from the symmetrical horn. Our 60-degree asymmetrical horn now has 17 dBi of gain compared to, I believe, 13 or 14 dBi of our symmetrical 60-degree horn. And then finally, our 30-degree asymmetrical horn now has 20.5 dBi of gain compared to 18 or 18.5 in the symmetrical. So again, we've been able to squeeze way more gain out of the wider ones specifically, and even optimize the more narrow 30-degree to give you a few more dB. So again, the beam shape is the important thing. It's asymmetrical. So you can see it's now wider in the azimuth cut than it is taller in the elevation cut. We also have a new feature called beam switch, which is highly unique. So the beam switch feature allows you to rotate the antenna 90 degrees and now make it, if you wish, 20 degrees wide and 30 degrees tall. So if you need even more AP density, maybe 12 30-degree horns is not enough, you can now operate this as a 20-degree wide antenna and therefore get 18 horns for 360 degrees of coverage, and again with now 20.5 dBi of gain. So it's a great feature, something new that we brought out with this new antenna platform, or this specifically the 30-degree asymmetrical horn. Just like all of our antennas, we really now, with the asymmetrical beam, get more of a sector type feel and shape to the coverage area. So now we get more gain, again, in a much wider coverage area, and still we're able to maintain the kind of small null zone because, again, the elevation cut is still taller than your traditional sector. So it really is a perfect coverage pattern now. So if you want to switch from a sector to a horn, perhaps based on gain, the symmetrical, asymmetrical horn antennas might be a much better match for you now, where the symmetrical horns may not have been. Just like all of our horn antennas, we have absolutely zero side lobes, right? So here again, we're looking at our asymmetrical 60-degree horn, and you can see again a quite beautiful, highly precise, highly uniform, zero side lobe radiation pattern on the left, compared to your patch array sector on the right that has tons of side lobes and leaks energy out of everywhere. So highly efficient use of radiation from our asymmetrical horn antennas. We're still extremely frequency stable, right? So as we change from the lower 5 to the upper 5 gigahertz, again, you can see that the beam pattern on the main beam doesn't fluctuate as much as traditional sectors do. So again, you get a much more stable coverage even as you change channels. A really important thing to point out is the balanced horizontal and vertical beams. Our vertical and horizontal beams overlap almost exactly. If you look at traditional sectors, you typically don't get this. You usually get a much wider and more narrow horizontal and vertical, and this creates problems with chain mismatch towards the edge of the sector or out in the front of the sector. Again, it's really important in today's multi-stream radios, these MIMO radios, whether it's 2x2 or higher, to make sure that you're delivering the same amount of gain in both polarities to the same area. So with a traditional sector, typically, again, you might have one polarity, let's say horizontal is 80 degrees wide, and the vertical might be 100 degrees wide, and on average, it's 90, so they sell you a 90-degree sector. So again, the real key here to our asymmetrical horns is the fact that we are able to, again, get both the vertical and horizontal beam patterns to match, which gives you the ultimate beam performance out in the field where your customers are, and patch array sectors just can't deliver and don't deliver this type of performance. It's really groundbreaking. It really is. So rural deployments are one of the main reasons for these antennas, right? So we know that rural WISPs have a challenge of low customer density. So rural WISPs usually have to cover much larger distances, and typically their customers are sparsely populated, and therefore you don't have maybe the budget to put up, let's say, 12 APs to cover 360 degrees in order to get the distance that you need and the 360-degree coverage. So the asymmetrical horn, now with more gain in the wider azimuths, allow you to go into these rural deployments and cover these WISPs, cover these customers, again, in lower densities, and still get all the noise immunity that horn antennas bring. I know a lot of people say, well, I don't have any noise out in my area, so maybe it's not as important. And I'll tell you, if it's not there now, it will be later. Noise will find you. I guarantee it. So, building out with horns from the beginning, even in low density rural deployments, is probably a smart thing to do in the front end. Otherwise, you'll be forced to forklift it later. So again, all the benefits of higher gain in the wider azimuths with all the noise immunity in our asymmetrical horns. Even though we only have 3 different sizes in our asymmetrical horn, again, for rural coverage, it still works quite well to be able to use, again, different sizes based on where your density is, right? So if you don't have to cover a far area, you can use a lower gain, wider asymmetrical horn versus the tighter, higher gain, more narrow asymmetrical horn. So you still get the ability to kind of create your coverage area based on where your customers are and only hear the signals you want to and not the stuff you don't. So really important there. Again, very durable. All our antennas are made with the same product. So again, we use, you know, extruded aluminum, zinc alloys, stainless steel, and high quality plastics in all of our antennas. So they're built to last and be out there for a very long time. Oh, it looks like we went out of sync here. I'm sorry. So now we're going to go over our symmetrical horn carrier class. So the carrier class horn is basically the same as the same performance of our symmetrical twist port antennas we saw earlier, except these have end connectors built into them. So our symmetrical horn carrier class, again, they have all the same RF performance that we saw earlier. The difference is that they have integrated end connectors built into them. So, you know, if you're a WISP that is using, let's say, a radio platform that we don't support with TWISTPORT, there's no need to buy the TWISTPORT horn and then that connectorized TWISTPORT adapter. If you know you're not going to switch radio technologies, you can just get them with the end connectors built in. So it makes it a lot easier for you. Again, if you're only running Mimosa and you're never going to run Ubiquity or something else, you know, the carrier class horn is probably the right one for you. Again, just trying to save you buying a second adapter for your antenna. The carrier class series is also offered in our ULTRAHORN, so you can get the carrier class version. Again, all the same benefits that we spoke about earlier of the ULTRAHORN. The only difference is you have the end connectors built in, and all these antennas can be easily identified by the red cap in the back. So again, here's some deployments of some Mimosa A5Cs with our carrier class horns. And even on the right over here, you can see that's a EPMP 2000 radio. So this was a customer that used the carrier class horn because at that time we didn't have a TWISTPORT adapter for it. So again, that radio at the time fell into a non-supported radio brand. So they just went with the ones with the connectors built in to make it a little bit easier. And then finally, our carrier class sectors. So we still manufacture traditional type sectors, the long form factor patch array sectors. This carrier class sector line is actually over 7 years old. It's one of the first sectors that we brought to market and that we still manufacture. We have two different types. We have a 2.4 gigahertz version that's a 14 dBi of gain, and then we have a 20 dBi 5 gigahertz version. So both of these can still be found from your distributors. Unlike the other traditional sectors, we've done some really unique things, specifically the built-in back shield. So this built-in back shield is, they're called frequency selective services. So these are like chokes. They allow you to attenuate signal. So rather than, you know, a manufacturer builds you a sector that leaks out the back and then you're forced to go spend money on an aftermarket shield kit to strap onto the sector to maybe make it work somewhat better, we decided to create the back shield built into the antenna, tuned and designed specifically for the antenna. And this gives you some great benefits, including co-location capabilities, but mainly it allows us to give you the balanced beam. So we spoke about a little bit earlier how your mainstream traditional sectors usually have one polarity that's much wider than the other. If you look on the left, our back shield allows us to manipulate the vertical and the horizontal beam so that way they overlap better. So again, no matter where your customers are, especially as they start getting to the edge, you're being delivered the same quality signal, the same intensity signal in both polarities. If you look on the right with those unbalanced beams from other mainstream sector antennas out there, you can see if your customer is towards the end, he may receive a higher intensity vertical signal than he does horizontal signal, therefore giving you the chain mismatches and therefore giving you very unstable MCS rates and other connectivity issues. So, so it's a great a great product and still being used today by some WISPs. Again, here are some deployments in the field. So again, you can see our carrier class sector in action. Again, it has a clip-in mount in the back, so it makes it compatible with most Ubiquity radios. You just slide and click it into place. It has the pigtail cover to protect the pigtail, something that we brought to market over 7 years ago first, that you'll now see in other antenna platforms out there to protect your pigtails from the elements, and as well as even the EPMP 1000 line. I believe we make a little clip-on adapter that will allow it to slide in. So it's compatible like most other radios, where you can just slide and click them into place. So at RF Elements, again, we're setting new industry standards. We really are, right? And we're doing this by creating noise rejecting antennas, specifically our TWISTPORT horn antennas. We, again, brought this concept to the market quite some time ago, and is really making a huge change in the industry. And you can start to see how the industry is shifting to this technology. The same could be said for the zero loss or near zero loss of the waveguide fed TWISTPORT adapter that, again, we brought to the market many years ago. When you combine this noise rejection and extremely low loss or near zero loss, you know, it's creating this massive scalability. This is the new standard for installs today. You know, it used to be that people were doing just an Omni, or people were doing 3 or 4 sectors for their deployment. The new standard now is like 12 antennas plus, and this is only possible with the horn antennas from RF Elements. And again, we're stepping up our game, and we're bringing new standards that are being adopted by the industry every day. Just to reiterate again, you know, again, our product line is very well built with high quality, very durable materials. So they're built to last and built to stay. And one thing that's very important to note is our stainless steel hardware. So when you use stainless steel hardware, you need to use an anti-seize lubricant. Stainless steel likes to bond and gald, and therefore, you know, bind up to each other. So if you use anti-seize, you're guaranteeing that you're able to connect and disconnect these screws later without ever having to worry about rust that you see on a lot of galvanized screws and mounting hardware in the field. So it won't rust, and it'll last a very long time. Just use some anti-seize on our screws and you'll be good to go. We also use ecological packing. So we now use reduced styrofoam and recycled cardboard to be a little bit more environmentally friendly. We have tons of customer testimonials. The YouTube channel is my favorite place to go. You know, hearing a manufacturer talk about how great their product is, you know, something that most customers and WISPs don't want to hear, right? So the best place is to hear it from other fellow WISPs like yourselves, right? So we have on our YouTube channel a great number of testimonials. We have this video series called WISP Traveler, where we travel the world and interviewed WISPs and asked them how they were using our horn antennas and how it benefited them. So, you know, you may be fighting a problem that one of these WISPs were fighting already, and watching a video will let you know how they utilize our antennas to get over these problems and grow their WISPs, along with other great videos on RF and how RF and antennas work. You can find our YouTube channel, again, customer testimonials, unboxing videos, how to use our products, a lot of great information there. So go visit our YouTube channel and see some of the context, including webinars that we've done like this one. We have an online community. You can see it at rfelab.com. You could join our forum. If you join our forum, you get a free t-shirt. We have a lot of cool t-shirts that a lot of people in the WISP community really enjoy. So if you've never been to a trade show and you'd like to get a t-shirt, you know, sign up at our forum. You can get a free t-shirt. And again, interact with a lot of WISPs that are out there. Ask questions to not only us, but your fellow WISPs, and see how maybe you can solve problems, get product announcements, and find a lot of good, useful information. So our trademark disclaimers. So, the third-party trademarks are used solely to reference the compatibility of RF Elements products. All rights and respective trade owners are reserved. So we simply use the trademarks and names of products that are on the market simply to, again, reference their compatibility with our products. And with that, we go to the Q&A. So Chad, I'd open it up to you. If we have any questions, I'd love to take them all. And if anybody has follow-up questions, please post them now, and I'd happy to answer all of them.
Yeah, feel free to be typing in any questions you may have. And I will, throughout this question that came in, do you see people using the uplink beamforming cambium antennas with horns?
So you can. Most people don't. However, it really depends on which of the horns you're using, right? So the beamforming antenna was really, created to kind of help fight noise, right? Well, when you use our horn antennas, you really don't have the problem of noise. I mean, of course, it still exists, but it's greatly reduced. So typically, if you're using, or I guess we should say, it's suggested that if you are to use, or if you want to use the beamforming antenna from cambium, you should be using it with horns that are 60 degrees or wider, simply because there's multiple arrays within that smart beamforming antenna. And if you utilize it with one of our narrow horns, like the 30-degree horn, which is quite popular, then you're not getting the benefit of all the arrays that are in there, and therefore it may not yield you a great difference. So again, most horn users don't use them, but you can, and if you want to, or you must, use it with a wider horn. So 60 to 90 degree with beamforming would be what's suggested. I hope that answers that sufficiently.
Another question is there any difference in construction and mounting hardware between the symmetrical horns and the CC symmetrical horns?
And yes, so the mounting apparatus is different. It's still the same two locking bolts, the only two bolts that mount either of those systems to your pole. The difference is the asymmetrical horn uses that different mount that we saw in the video, where you mount the mount to the tower and then you slide, or you drop and slide the horn antenna into that kind of articulating part of the bracket, where with the symmetrical horns, it's just the two bolts that lock it in place. And again, you can see a lot of this stuff on our website. If you go under the product view, you can see the difference between the two mounts.
All right, and another question, do you have any recommendation for noise reduction for 900?
No, we don't make any 900 megahertz antennas, unfortunately. So, I mean, it's really difficult. If you look at the antennas that are used for 900 megahertz, I mean, they're just horrible. First off, they're either, really high gain omnis, which are terrible. Really high gain Yagis, which have tons and tons and tons of side lobes, or you're using traditional sectors. So unfortunately, there's really nothing we can do at RF Elements, as we don't have any 900 megahertz antennas. It's really just a really tough spectrum to operate in, unfortunately.
And a similar question, just asking for your thoughts on 2-4 horns for those who are still using that range. I mean, your perspective on that as well.
Yeah, so I mean, at the moment, we don't have 2.4 gigahertz horns on the roadmap, simply because of their size, right? So a 2.4 gigahertz horn would be more than 2 times the size of our 5 gigahertz horns. On top of that would probably be 2 times the price of our horns, which might put them out of the price range for most WISPs. And then on top of that, even though the size doubles, the gain actually gets smaller. So in order to deliver even close to the amount of gain you want, you're probably talking about 3 times the size of the horns we have now, which again makes it even more expensive. So we're not ruling it out, but it's certainly not on the front of our roadmap. We're looking at interesting ways to kind of deal with 2.4, and right now it's probably not with a horn antenna.
Okay, and one more here. Is GPS sync still necessary for AB channels with co-located horns like it is with sectors?
Yeah, so absolutely. It's in order to get this really high density. So people who are utilizing horns can typically run 2 channels on their towers, right? This is not the case. I'm not making this as a blanket statement, just to be clear, but there are many WISPs with GPS synchronization running AB with 30-degree horns. We have a WISP running 12 APs, only utilizing 2 40 megahertz channels. So GPS sync certainly makes it a lot easier. Is it possible to reuse channels with horns without GPS? It is, but you still need a lot of isolation, right? So you need a lot of space between the horns in order to do that. You probably won't get AB. You could probably get away with ABC with 3 channels. As you go to the 90-degree with the 30-degree horn, so by the 3rd one, you might be able to reuse that 1st channel, again, with space. Some people are deploying on water towers where you have the water tower or the structure giving you great physical isolation between the antennas. Again, so it's possible to do it. GPS sync really makes it way more easier, but it's something you have to try. It just depends on the installation. There's no cookie cutter. Here it works, here it doesn't. So try the horns and let us know how it works for you.
Great. Okay, we're going to cut it there. That's the end of our questions, and thanks for all those who stuck around. Thank you again for attending, and we will be sending you a recording of the webinar so you can review or share. And just keep an eye out on DoubleRadius for future webinars and in our social. And take a moment to fill out the survey that will appear on your screen. And with that, thank you very much, and we'll see you next time.
Thank you, everybody.